All right. Let's jump really quick to this box. Put your phones away, get your notes out, please, quickly, quickly. When I say put your phones away, guaranteed Josh will have talking to you. What? Put your phone away. Josh, you're next. Always Josh. Okay. Now let's talk really quick between the difference of series versus sequence, and then finite versus infinite. So these two columns are talking about sequences. From day one, do you remember what a sequence is? It's just a list of numbers. So 1, 4, 7, 10. 1, 4, 7, 10, dot, 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 dot. What's the difference between finite and infinite? Finite has a stopping spot. So if there's a finite set of numbers, that means I can count them. They're done with the number. Infinite means it goes forever. Now the difference between a sequence and a series, let's use the same number, is the ability to add them. So if it's a finite series, can you add them up and get a number? Yeah, sometimes it's going to be really big, but it is possible to add these together, 5, 12, 22. Is that right? Infinite series, can you add those up and get a final number? No. Almost never. However, there is a time that perhaps you could. Depending on, well, right now we're just talking arithmetic. If we're just talking arithmetic, then no, you would never be able to add up an infinite series. So, we're going to come up with the equation. S is going to stand for sum. And we're going to come up with the equation using the story above. So there's a little boy who's actually a famous mathematician, not like basketball star famous, but mathematician, that was a little troublemaker. He was bored in class and so he was causing some problems. So his teacher just wanted to be rid of him. And he said, child, count the numbers from 1 to 100, thinking that that would take a while, or 1 to 1,000, or 1 to 2,000. It would take a while, right, to count up all those numbers. So he gets to work, and well before the teacher thought that he should be finished, he was finished. And he got the answer, 5,050. So all of the numbers added together is 5,050. So then the teacher, how did you do that? So let's just start by listing. Is this finite or infinite? Finite. So you wouldn't have to, but say you listed all of the numbers from 1 to 100. How would you count those quickly? And that would have taken the kid a long time, and the teacher would have won. Yes. Do you notice anything about those numbers? Now, I put the end numbers on there for a reason. Haley? Oh, good idea. So these two are 100. These two are 100. Those two would be 100. That's really close to what he did, but that's not quite right, or not quite exactly what he did. Let's use Haley's idea though. Let's not take the 1 and the 99. Let's take the 1 and the 100. What does that add to these? In fact, maybe if we reorganize these, so it's 1 and 100, 2 and 99, 3 and 98, 4 and 97. We notice that he's got pairs of what? 101?
101.
No, why 50? Because we paired the twos, right? So we take the 101, which is that's how many, they're all 101s, right? And how many of them are there? 50. And we get the 50-50. Now let's come up with a formula using this idea. Now this story, I hope, will help remind you what the formula is, because there's a lot of formulas to memorize. What did we do? We took the, what term in the series is that? The first term, and we took the final term, but in the final term I can only call it a to bed because I don't know right now in the general formula what the final term would be. In this case it was 100, right? But in the, if it was 1 to a million, then it would be the millionth, whatever. Now what did we multiply that by? Half of the terms. So what letter is going to represent how many terms there are? N over 2. So I half the amount of terms and multiply that by the first added with the last. And that's the formula. I don't need to know the difference. I don't need to know anything besides the first term, the last term, and how many terms there are. The mathematician, by the way, his name is Gauss, and he's the one that did this. So let's use that formula to see if we can come up with some sums here. The first 4 rows of chairs are set up for a meeting. The first row has 4 chairs, and each consecutive row after that has 2 more. So 6, 8, and so on. The seating pattern continues until there are 15 rows. How many chairs will there be in all 15 rows? So this is a sum question, right? I want to know how many chairs the kids have to set up before the event starts. I don't like it. You don't like it? We like 1 to 100. So what do we need? Based on the formula, we're going to need to know what n is. We need to know what a sub 1 is, and we need to know what a sub, in this case, 15 is, right? Why did I say 15? Because that's how many rows there are, which means n equals what? 15? Is that okay? What's a sub 1 in this case? 4. How would you get a sub 15? There's 2 ways. You could either 10, 12, 14, 16, 18, 20, which is fine if there's only 15 rows, but if there was 150 rows, would that be practical? No. So we have to go back to day 1. How would you write a formula for this sequence? A sub n equals the difference, which is 2, right? And plus the term before if there were one, 2. And everyone paying attention, please, which means looking at the board is probably key factor. Can we use this now to find the 15th term? Let's do that. Equals 2 times 15 plus 2, which would be 32. Now do we have everything that we need to plug it into the formula? We want to add up all of the numbers from 4 to 32, and it's skipping the odd ones. So you start by saying the sum equals how many there are, which in this case there are what? 15 rows, divided by 2, because that's part of the formula, times the first plus the last. Plug that into your calculator. What do we get? Say it again. 270. Did I hear you right? My grandma had hearing aids when she was like 22, so the fact that I'm 35 and still without them, I'm feeling pretty good. But yeah, I struggle a little bit. Okay. Well, true story. And she couldn't see either, like her side vision was totally gone. So you could be standing right next to her and talking to her, and she'd look for you because she didn't know where you were. Anyway, it was awful. All right, let's try the next one, and then it'll be time to back up. What is the sum of the even integers? So this is kind of critical, from 2 to 100. So what do we know? A sub 1 equals what? A sub 1 equals 2. A sub, the last one equals 100. And what does n equal? How many even numbers are there from 2 to 100? There's 50, right? Half of the numbers. Yeah. So, even is the highest number, yeah? So if I want to find the sum, I take the number, which in this case is what? The number of numbers? 50, divide by 2, n is the number of things. So in the first example was chairs. The number of terms, I guess, is the best way to say it. And then multiply it by the first number, add the last number, and what do we get? Somebody confirm? Yes. Good. He talks the whole class period, but he's like a walking calculator. Good job. All right. As you leave, I would like you to try part C. just hurry and think about it really quick. Jot it down. That is the end of part 1.